All right, we're going to start the second part of chapter 4. So chapter 4 is split into two parts. We just finished the first part. The second part, we're doing sections 4.4, 4.5, 4.6, and 4.7. And then we're also adding in two sections, chapters 6.1 and 6.2 into this. So just kind of as you are thinking about it, they all relate to trig and trig functions. And so we're kind of putting these two things together to hopefully make it all kind of come together for you. So what you should learn in this section is that we are going to evaluate trigonometric functions of any angle. We're going to find reference angles, and we're going to evaluate trigonometric functions of real numbers. So just a reminder, we have talked about SOHCAHTOA in the last chapter, right? So we had SOHCAHTOA was our ratio for our trig functions. Our SOHCAHTOA, right? And that gave us that our sine was opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent is opposite over adjacent. And then the secant, cosecant, and cotangent. So you could remember those with Cho-Shikeo. Or you could just remember those are reciprocals. So what's going to happen in this chapter is that maybe instead of giving you triangles, we're going to look at this in terms of angle measures. So if we have an angle measure and we end up, we're going to say, I'm going to change my color so we can see this. So in this picture, we end up at this point here, X and Y. What we can do is we can create right triangles to help us find sine, cosines, and tangents, right? So what would happen is if you were to drop a vertical line straight to your x-axis, it forms this right triangle, right? And we have our values. So this x we would call a negative x, and this y we would call it y, and then this is what we would call r, right? And we would just use the negative x in this case because it's negative on the x-axis. So if we were writing ratios for sine for this angle measure right here, what we'll get to later is that this is the reference angle. So the sine of the opposite over the hypotenuse is the same for both of those. Same thing for tangent, cosine, and all of your other functions. Right, and so here's kind of that explanation for this, for why the radius is your x squared plus y squared. It's that Pythagorean theorem. However, though, remember that your radius can't be 0. That wouldn't make any sense to have a triangle with the radius of 0, because then you wouldn't have a triangle. Okay. We do know, though, when x is 0, the secant and tangent are undefined, because remember that x really goes with your cosine value, and tangent is sine over cosine, and secant is 1 over cosine, right? So if cosine is 0 or x is 0, you would have a 0 in your denominator, and it would be undefined. All right, so let's look at this first example. We have the point -3,4 as a point on the terminal side of the angle, and we want to find the sine of theta, the cosine of theta, and the tangent of theta. Okay, so our first step is let's create a right triangle, and you always create your right triangles. So when we're making this triangle, so we're going to make a right triangle with the x-axis. Okay, so you always make your triangles with the x-axis. So when we make this triangle and we label the sides, I know it doesn't make sense to have a triangle have a negative side length, but I would still put a negative side in there just so that way it keeps your values for your sine, cosine, and tangent. If they need to be negative, then they'll be negative. So this side right here is -3. This side right here is 4, right? Because that's how we got to that 0.34. And then if we use Pythagorean theorem, if we say 4 squared plus -3 squared equals our r squared, we end up with that r is 5. So you're going to have to use Pythagorean theorem to find that third side of your triangle. And then once you have the three sides, we're now talking about this angle measure right here. It's the same as this one, right? They're supplementary because they add up to 180, so it will all work out for us. So we could say that the sine is opposite over hypotenuse. So our sine is 4/5. Our cosine is adjacent over hypotenuse. So our cosine is negative 3/5. And that's why we keep those negatives where they need to go. So your sines and your cosines and your tangents have that right positive or negative. And our tangent is opposite over adjacent. So we would say 4 over negative 3. A reminder for your quadrants. Okay. In the first quadrant, sine, cosine, and tangent are all positive, right? Because your x and your y are both positive in the first quadrant. In the second quadrant, sine is positive because that's with your y value, right? And y is positive in the second quadrant. Cosine is negative because your x is negative. And remember that your tangent is your sine. I shouldn't have used an x there. Let's erase that because that'll get confusing. Your tangent of theta is the sine of theta over the cosine of theta. So in that second quadrant, if sine is positive and cosine is negative, when you do a positive divided by a negative, you would get a negative. Quadrant 3, your x and y are both negative, so sine and cosine are both negative, which makes the tangent positive. In quadrant 4, sine is negative, cosine is positive, so when you divide those, the tangent would be negative. All right, so let's look at example 2, and it says find the exact values of the 6 trigonometric functions of theta by finding a point on the line 2x plus 3y equals 0 when the terminal side of theta lies in quadrant 4. So for a problem like this, we know that our angle measure is going to be in quadrant 4. So it would make sense, right? Draw your axes. And what we find is that if we go revolve around, we're going to be in this quadrant. So this is quadrant 4 over here. We're going to end up in that quadrant. And so we have a line, 6 trigonometric, by finding a point on that line, right? So we have to figure out a point on this line. So here, if we have 2x plus 3y equals 0, we get 3y equals negative 2x, which means that y equals negative 2/3 x, right? Well, negative 2/3 is our slope. They told us that our line is going through the origin. So if I go through the origin and then I rise negative 2 and I run positive 3, right? That puts me in that fourth, right? So that puts us in the fourth quadrant. So what we can do is then just draw this line just in the fourth quadrant. So this is the line that we're talking about, that 2x plus 3y equals 0. And so now we want to find the 6 trig functions. So remember, we're going to make that triangle with the closest x-axis. And then this is our angle measure that we're talking about right here. So let's label our sides. Okay. We went over positive 3 on the x-axis, so that side is 3. We went down 2 on the y-axis, so I'm going to make this side negative 2. And then I'm going to use Pythagorean theorem to find my third side, which we'll call r. So 3 squared plus negative 2 squared equals r squared, or 9 plus 4 equals r squared. So 13 equals r squared, which means that r, when we take the square root of both sides, r is the square root of 13. Leave these exact, okay? Don't write these as decimals. Just leave your sides, if they're square roots, then leave them exact. And so now we have all 3 sides. And so now we just have to write our ratios. So the sine of theta is opposite, which is negative 2 over hypotenuse, square root of 13. Okay. I don't need you to rationalize when you're doing these. On your homework check, it will probably require it, but just in your general homework, I don't need you to spend the time necessarily doing that. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And what you'll actually find out with these problems is that the slope of your line will always be the same as your tangent. So that's kind of a quick little check that you can do. The cosecant is the reciprocal of sine, so root 13 over negative 2. The secant is the reciprocal of cosine, so root 13 over 3. And the cotangent is the reciprocal of tangent, so we get negative 3 halves for that one. And those would be your 6 trig values. All right, reference angles are actually kind of helpful because they can help you in determining values. It's just an angle in standard position. So if you have some angle in standard position, its reference angle is the acute angle theta prime. So there's supposed to be that little apostrophe there. It's just your prime formed by the terminal side of theta and the horizontal axis. So to give you a visual of this, if we went back to this previous example, if we were to have thought about this, we rotated this angle all the way around like this, right? So this whole big theta was our actual angle. But what we did was we just found this little angle here between the terminal side and the x-axis. That was an acute angle. So that was our reference angle. Okay. So when we talk about reference angles, that's really what we're looking for. So here's a few diagrams that show reference angles, like for what quadrant. First quadrant doesn't have any reference angles because they're just already in the first quadrant. So to find the reference angle in the second quadrant, you could just do pi minus the original angle or 180 minus the original angle. Okay, the third quadrant is really this angle right here. So to find that, you would do theta minus pi or 180 minus theta. And then in the fourth quadrant, we're talking about this angle right here. So you could do 2 pi minus theta or 360 minus theta to find that reference angle. So let's just find some reference angles here. For part A, 300 degrees is in the fourth quadrant. So to find our reference angle, we're going to do 360 minus 300, which would give us 60 degrees. So 60 degrees would be our reference angle, which means if we needed to find like the sine of 300, we could actually just find the sine of 60 and it would be the same thing. All right, theta is 2.3. So this is in radians, right? Because there's no angle measure. And so we have to think about where is 2.3. So visualize your unit circle. Right here at the top is pi over 2, and over here on the side is pi. Right? And we all know that pi is 3.14. Right? And pi over 2 is 3.14 divided by 2, which is about 1.57, if we were talking about these in decimals. So we know that this 2.3 is in quadrant 2. Right? So maybe 2.3, maybe it's about right here. Right? So this is 2.3 radians. So to find our reference angle is this angle right here. We're going to do pi minus 2.3 to find our reference angle. And so if we do pi minus 2.3, we get 0.842. So our reference angle here is 0.842. Right? If we think about this next one, negative 135 degrees, that means we're rotating in a negative direction. So if we rotate to here, we're at negative 90, and another negative 45 gets us here. Right, so this is negative 135 degrees. And remember, if we're in that third quadrant, if we went back here, in your third quadrant, if we're in degrees, we're going to use our theta and subtract 180. So if we did theta, though, negative 135, and you subtract 180, right, we're still negative. So if we have negative 135 and we subtract 180, we're at negative 315. Okay. So that doesn't necessarily help you on that one when you have the negative angle measure and using that rule. So what I would probably do first is I would actually make my negative angle positive. So if we were to add 360 degrees to this, we would get 225 degrees. Right? And so then this is that positive angle that we want to use. So if we did 225 minus 180, then we would get 45 degrees for our reference angle, and that would be what puts us in the first quadrant. So if you start with a negative, find a positive angle that would be in that same spot by adding either 360 or 2 pi, and then you can find that reference angle. All right, so this next example, the figure shows each angle and its reference angle, and that's that theta prime. So sorry about that. This example 4 is not really your example 4, it's your solution. So this was just what we found from when we just went through example 4. For some reason, I thought that was a new example. All right, so our next thing we need to talk about are the trig functions, right? And so this was kind of what we did in example 1, where we use the reference angles to help us find our trig functions for triangles. Okay, and remember that just the definitions that you know the sine of theta is y over r, which is your opposite side over your hypotenuse. And you know that the tangent is y over x, right? And we know that the cosine, I'm not sure why cosine got left out of here, but cosine of theta is x over r, which is your adjacent side over your hypotenuse. So just remember those ratios. And so when we go down here in the next one, evaluating your trig functions of any angle, it's the idea that we can always use our reference angle to help us find our actual trig functions. So just depending on the quadrant, you just have to pay attention to that, and you have to pay attention to what quadrant it lies in, or just make sure that you label the sides with positives and negatives. In this next slide, we've included a table of your exact values in radians and degrees, just as a reminder. But again, this is that first quadrant of the unit circle that we really need to have memorized at this point. So let's look at example 5. Let's evaluate each trig function. So what we're doing is we're trying to find the cosine of 4 pi over 3 for this first one. So remember that 4 pi over 3 is right here. So your reference angle is pi over 3. So the cosine of 4 pi over 3 will equal the same thing as the cosine of pi over 3, right? And from your unit circle, you know that the cosine of pi over 3 is 1/2. So the cosine of 4 pi over 3 is also 1/2. The tangent of negative 210 is this angle right here. So your reference angle is 30 degrees. So this would be the same thing as the tangent of 30 degrees, right? And the tangent of 30 degrees, you can either have that memorized as the square root of 3. If you don't have your tangents memorized, then you would have to do the sine of 30 divided by the cosine of 30, right? the sine of 30 degrees is 1/2. Sorry, going back here. The tangent of 30 degrees is root 3 over 3. I misspoke on that one. So if we're solving this, the sine of 30 degrees is 1/2. The cosine is root 3 over 2. So when you do 1/2, instead of dividing by root 2 over 3, your 2's would cancel, and you get 1 over root 3, which when you rationalize gives you your root 3 over 3. And then the last one, if we need the cosecant of pi over 4, our reference angle is pi over 4. Let's use reciprocals. So that would be the same thing as 1 over the sine of pi over 4. The sine of pi over 4 is root 2 over 2. So the reciprocal of that is 2 over root 2. And if we rationalize, not a 3, but a 2, if we rationalize, you get 2 root 2 over 2, which would just simplify to be the square root of 2. So moving on to our next example, it says let theta be an angle in the fourth quadrant such that the cosecant of theta is -3. So if cosecant's -3, then we know that the sine is -1/3 because they're reciprocals. And we need to find cotangent using trig identities or right angles. So I'm going to show you both ways. So if we were using identities, then that's using your formula sheet. And if we need to find the cotangent, right, we know that cotangent, or the identity, is that 1 plus cotangent squared theta equals cosecant squared theta. And they told us that cosecant's -3. So 1 plus cotangent squared theta would equal -3 squared. Or 1 plus cotangent squared theta would equal 9. So cotangent squared equals 8. And that would mean that the cotangent would equal the square root of 8. But you have to think about this, though. We are in quadrant 4, where your x is positive and your y is negative. So cotangent would need to be -√8. Or if you simplified, -2 root 2. So that's one way to do it using identities. Now the other way is with right triangles. Okay. So what I would do is if they tell you that it's in the fourth quadrant, sorry, my lines aren't all straight there, is I would say, well, I'm going to draw a triangle, a right triangle, in the fourth quadrant where I have my angle measure. So just like we've been doing in the last couple examples. Okay. If cosecant's -3, and we know that the sine is -1/3, remember that your ratio for sine is your opposite over your hypotenuse. So if we were to label this triangle with that ratio for sine, our opposite side is 1. Our hypotenuse is 3, but sine's negative, and you notice that this 1 went in the negative direction, so that y side is negative. Then we could go through and use Pythagorean theorem to find that other side. So again, if we call that side x, we could say x squared plus -1 squared equals 3 squared. So x squared equals 9 minus 1. So x squared equals 8, which means that this side is the square root of 8. Okay. And then we want to find cotangent. Okay, so cotangent, remember, if tangent is opposite over adjacent, then the cotangent would need to be the adjacent over the opposite. So when we're looking at our triangle, our adjacent side is root 8 and our opposite is negative 1. So our cotangent of theta equals root 8 over negative 1, which is negative root 8, or we could say is negative 2 root 2, which is the same answer that we got on the other part over here.